In this class, we are going to discuss about the analysis of clocked sequential circuit. Okay, so this analysis of clocked sequential circuit topic is very simple topic, and it is very important topic for long answer. Okay, remember this one. So this analysis part is part that is actually whatever the circuit we have, that circuit is working properly or not, we will check it here. Okay, and also we have to check that the circuit output is what and what the circuit is going to perform. So these steps of operations we will do here. Okay, now we'll see. So this analysis of clocked sequential circuit having some procedure for designing a circuit. Okay, so what are the procedure we are having, what are the steps we are having, now we'll see here. So this analysis procedure generally consists of 5 steps of procedure while designing the circuit. Okay, so first step is a sequential circuit is given which describes the behavior of the circuit. Okay, so that means directly they given one sequential circuit, so it describes the input and output equations. Okay, so now coming to the second step, that is obtain the state equations at the input of the flip-flops. That means whatever the sequential circuit they given, so in that we have to describe the input and output equations. Okay, so step 3 is nothing but obtain the output equations. So we have to find out the input and output equations in step 2 and step 3. And coming to step 4, determine the state table for all possibilities of input and output values. That means, so already in before step we did input and output equations. So with the help of input and output equations we have to find out the state table. Now coming to the step 5, that is the last one, draw the state diagram. Okay, so first of all, this analysis procedure of the clocked sequential circuit in step, what is the procedure we have in that means, first they given one problem. The problem will consist of the logical diagram or sequential circuit. Okay, so that sequential circuit having some combinational gates, or it may be consist of some flip-flops, like that they given one sequential circuit. So in the step 2, we have to determine the input and output equations. So that means first of all in the step 1, whatever the circuit we are having, we have to verify whether the circuit is sequential or not. So first we have to check it. Okay, whatever the circuit we are having, is it sequential or not, we have to check it in the first step. And coming to the second step, after verifying that circuit, so then we'll go with that finding the maybe combinational gates equations or maybe flip-flop equations. We have to find it, that we can call it as input equations. And coming to the output equations, so based on that circuit how many outputs we are having, so first verify that, after that we'll finding that equations also. And coming to the step 4, so determine the state table. So already previous step we have to find out the already we find out the equations, right? So that is nothing but Boolean equations we knows. So with the help of that equations we have to find out the state table. Okay, so now in the last step we have to draw the state diagram. Okay, so in one by one we will see that. Let's see one example. With the help of that circuit we have to find out this analysis procedure. Okay, so see here we'll have an example problem here. Directly they given one logical circuit diagram. So they given this is the sequential circuit. So first in step 1 what we will do here, this is completely numerical part ma, so there is no theory part here. Whatever the circuit we are having, we have to verify whether the circuit is sequential or not. Okay, so we have to check it first. So here see, this circuit consists of generally, these are nothing but flip-flops, no, that we will be consider as single input, that we can consider as the D only. So simply we can say that this is a D flip-flop, right? And also some of the gates are involved in this circuit. So like 2 gates with OR gate and 1 AND gate and 1 OR gate, NOT gate and AND gate. So that is nothing but it is consist of some combinational logic gates. Okay, so and also here this flip-flop circuit having the feedback path. See here, feedback path is nothing but whenever the output is connected back to the input path, so that is called as the feedback path. So see here, this is the flip-flop having the output, so this output is connected back to the input stage. Here also output is connected back to the input path also. So that's why we can say that clearly this circuit is a sequential circuit because it consists of the combinational gates as well as flip-flops with some feedback connection. Okay, so this is the first thing, will clear that, right? So now coming to the, we have to check it out. In step 2, what we will have, find out the state equations at the input of the flip-flops. So find out the input equations at the input flip-flops. So see here, this is the output part for flip-flop 1 and this is the output part for flip-flop 2, right? So here, this is the D we are having now. So this D flip-flop having input is nothing but this is the previous part. So before the flip-flop, whatever the circuit we are having, that is input part of the flip-flop. So now we have to determine these equations for the flip-flop, that we can call it as the flip-flop input equations. Okay, so how to determine the equations means, first we should find out the gates outputs, then only we'll get the flip-flop. Okay. Okay, so let's find out the first gate outputs. Each and every gate output we should find it. Okay, so see here, this is the first AND gate we are having. So this AND gate consists of two inputs. So one of the input is directly we know that is X, right? So this is the X line we are connecting to this AND gate, and one more input is, what is this line means, here you have to verify where we are having this line. So that means from where it is connected means from A it is connected. So that is nothing but this line, whatever the line we are having, that we can say that A line. Okay, this line completely we can say that A line. So that A will be connected here and one more input is X. So you should represent A and X here. Like that you will write all the inputs of all gates. So this gate is nothing but one of the input is connected here. So what is this line? So this is nothing but X, and this line is nothing but where we are connecting this line. So see here, from B it will be connected. So that means we can say that this line we can represent it as B line. Okay, so you know this is the one B input of AND gate. Like this way, here also verifying that inputs. So this line will be as X and this line will be connected from A complement. Okay, so now this is the A complement. Okay, so now coming to here, this OR gate consists of the B line. So this is the B input and this line will be A. Okay, now coming to here, NOT gate. So this NOT gate is connected to the X. So now finding the results of all gates. Okay, we have all gates of inputs. Now finding the output of each and every gate here. So this is the AND gate now, we'll have product. So that means AX. And here, this is also AND gate, we'll get the product BX. So by combining these with OR gate, so then we'll get it as addition in between these two outputs. So AX plus BX. So now coming to here, so this is nothing but A complement X. So but which gate we are having? AND gate. So product. Now coming to here, this is OR gate. So OR gate means addition we have in between two inputs, A plus B. And this is the X with NOT gate, no complement we should apply. So X complement. Okay. So now finding the result of this gate, that is nothing but both will be with AND gate. So that is nothing but product will be having in between these two inputs into X complement. Okay, so these are the combinational gates outputs. So now clear, right? Each and every gate output we know. So now we'll go with the procedure. So now we'll solve this equation. First one is sequential circuit is not means already verified. This is a sequential circuit, that is a step 1. Okay, so I should write it here. The first step 1 is it sequential circuit or not? Yes, it is a sequential circuit. Sequential circuit. Okay, so and it consists of how many inputs and how many outputs and how many flip-flops it consists. Now we have to verify it. First it just consists of the two inputs. Okay, so now we'll write the first how many inputs it consists and how many outputs it consists. Now we'll see here. So inputs is nothing but before the flip-flop, that means before the flip-flop circuit whatever it consists, that is input, and after the circuit whatever we have, that is output. Okay, so see here, this A and B is nothing but generally we can call it as flip-flop outputs, but here we cannot use as that both will be we are not considered as our outputs, because A and B will be connected as our feedback connections, because these two are again connected as input part, right? So that's why here input will be considered as one of A, X. Okay, so input is nothing but X here. Okay, and the output we should consider as Y. Okay, so input is X and output is Y. So here why don't we consider AB as our outputs, means actually AB is having the feedback connection. That's why these two AB inputs, AB outputs will be considered as our inputs of combinational gates. Already we used here AX, BX and A complement X, like that we are used. So that's why we cannot consider as AB as our inputs, but we can consider as AB as our variables. Okay, so that means you can consider as present state variables. Those are A and B. Okay, input is X, output is Y, and the variables will be A and B. Okay, so now it's clear. So this is the first step. Now coming to the second step. What it will do in the second step? State equations at the inputs of the flip-flops. So we have to find out the input equations at the flip-flop stage. So flip-flop input is nothing but here only, na? So here what we will get the result, that is our input equation. Before the flip-flop, whatever the result you got, that is our flip-flop input equation. So see here, D is connected with which result? AX plus BX. And here also another flip-flop will be connected as A complement X. Okay, so that input equations. So first one, first flip-flop with respect to A, no? So that means D with respect to A. D suffix A. So dA is equals to, what is the equation? AX plus BX, like this way. So D with D suffix with B means is nothing but here second flip-flop. So that input equation is A complement X. So now we will get the two equations, that is the input equations of flip-flop. Okay, flip-flop input equations. So now coming to the step 3. So what is the step 3? That is nothing but obtain the output equations. We should find out the obtain output equations here. So already we have the output here, that is Y. We knows that. So what is the Y result here means in the circuit? So Y result is A plus B into X complement. So now in step 3 we should write it as output equation. Output equation. So Y is equals to, what is the result we got? A plus B into X complement. Okay, A plus B into X complement. So step 3 is also cleared. Now coming to the step 4. Step 4 is nothing but determine the state table for all possible input and output values. So that is nothing but the step 4. We should find it as state table. State table is nothing but generally describes the present state, inputs, next state and output values. Okay, so the relation between input and output values we can say that is state table, but here clearly mentioned the state table will be described as present state, and if you are having input, so then you can place it here, input, and if you are having present state in the circuit diagram compulsory, then it will be exhibit as next state also. Okay, compulsory, if the present state is there, the next state will be follow that. Okay, and the next one is output is there, so yes, output is there, so you can place it as it is. So now we'll place it that values, whatever the variables we are having, that will be placed it in this state. So first present state variables, what are the we are having? So in the circuit diagram we are having AB. So as it is, you can place it AB. And coming to input is what here? So that is X. Next state. So whatever the in present state we are having, so the next state will be follows to the present state only. So then you can place it as it is AB. Okay, so then output will be is nothing but here whatever the output variable you are having in the circuit diagram, as it is you can place it. Okay, so now we'll represent the state table. So already inputs output values we know. So after placing that variables, then we can start the state table. Okay, so now find out the state table with the help of this input values. So first, before taking that input values, first we'll mention the present state values here. So present state, how many variables we are having here? So we are having two variables, so A and B, right? So A and B is nothing but two variables we are having. So how to write the binary combinations means with the help of these inputs we'll write it binary combinations. So here we'll have the two inputs now. So then we'll get it as four possibilities, that like 0 0, 0 1, 1 0, 1 1. Okay, so these are the present state variables we are get with the help of binary combinations. So 2 power n is nothing but here 2 square we are having. So totally 4 possibilities, 0 0, 0 1, 1 0, 1 1. Coming to input, so for this also we have to write the binary combinations. So input only we are having single input. So single input is nothing but how many possibilities we are getting? So that is nothing but 2 power 1. So only two possibilities, that is either 0 or 1. So you can place it for this 0 and 1, 0 and 1. So 0, 1, 0, 1. Okay, so for 1 also we have to mention the input present state values. So for input 1, for input 0, both the values, for the both the values we have to mention the present state values also. So that is nothing but for this 0 1 case you may get the 0 0 condition. For this 0 1 condition also you may get the 0 1 condition. So for 1 0, for 1 also, for 1 1 case 0 and 1 1 case also. Okay, so I can divide it this one. So that means for two inputs you may get the two possibilities. Okay, so now coming to the next state value. So how to find these next state values means here, you know the next state equations, that is nothing but dA dB input equations we are having, right? So that's two equations we can consider as the next state equations. So with the help of these two equations we'll find that these results. Okay, so now here we have the A value, B value and X value. So first dA is nothing but, here I mentioned, next state is nothing but dA and dB. Okay, so dA value is nothing but, what is the formula we are having? AX plus BX, and dB value is nothing but A complement X. Okay, so now find it. First dA value, that is AX plus BX. So AX is nothing but 0 into 0, 0 plus BX 0 into 0, 0. So 0 plus 0 will get the result becomes 0. Like this, 0 into 1, 0 plus 0 into 1, 0. 0 plus 0, 0. Next, so 0 into 0, 0. 0 plus 1 into 0, 0. 0 plus 0, 0. Next, 0 into 1, 0. Next, plus 1 into 1, 1. So 0 plus 1, 1. Next, 1 into 0, 0 plus 0 into 0, 0. Next 1 into 1, 1 plus 0 into 1, 0. 1 plus 0, 1. Like that. So 1 into 0, 0 plus 1 into 0, 0. So 0 plus 0, 0. 1 into 1, 1 plus 1 into 1, 1. So 1 plus 1, 1. So this is the ax plus bx value. So now coming to the a complement x value. So a complement is nothing but, so you know a value should be represented as normal value. A complement is nothing but exactly opposite of that value is a complement, right? So imagine here in place of 0 you may imagine like 0 as 1 and 1 as 0, right? Here I am representing a complement and okay, so a complement I will write it here for imagination purpose. Okay, for understanding purpose I will write it here a value, but don't mention that a complement value. Okay, so like this you don't mention, just you can thought a complement as opposite of the a value. Okay, don't mention that in the table a complement value. So for the 0, 1 we will consider, and 0, 1, and this is 2 will be zeros, so you can consider as 1, 1, and these 4 values will be considered as zeros. Okay, so this is the a complement we are getting, right? So for 4 zeros, 4 ones, and 4 ones, 4 zeros we are getting. Now we should find it as a complement x. So a complement we are having and x we are having. So now multiply both the values. 1 into 0, 0. So 1 into 1, 1. 0 into 1, 0. So 1 into 1, 1. So 0 into 0, 0. 1 into 0, 0. 0 into 0, 0. 1 into 0, 0. Okay. So this is the a complement x that will be equal to the db value. So now we will find out the y. So what is the y result actually? A plus b into x complement. So here a plus a value, b value will be directly we can take it. But what about x complement means? So x complement again I will mention for understanding purpose. Okay. So here I will write it. So 0 place you may get it as 1, and 1 place you may get it as 0. So 0 1 0 1 0 1, right? So that means you may get it as 1 0 1 0 1 0. So now x complement we knows. So first add these two values, after that multiply with this x complement. So 0 plus 0, 0. 0 into 1, 0. Next 0 plus 0, 0. 0 into 0, 0. Next 0 plus 1, 1. So 1 into 1, 1. Next 0 plus 1, 1. 1 into 0, 0. 1 plus 0, 1. 1 into 1, 1. So 1 plus 0, 1. 1 into 0, 0. 1 plus 1, 1. 1 into 1, 1. 1 plus 1, 1. 1 into 0, 0. So this is the output y. So like this you will find out the state table. Okay, so how to write the state table? So the state table determines the present state, input and next state and output values. Okay, so present state how to consider means what are the variables you are having in the flip-flops, that we can consider as the present state. So the next state is nothing but it will follows the present state only. Okay, so input is nothing but if you are having input single or double you can check it. So if you are having single input you may get it as 2 possibilities like this. If you are having double inputs then you may get it as 4 combinations like this. Okay, so then next state already you have the equations. So with the help of that equations you can find it the result. Okay, so this is the state table. So now after finding the state table, then we'll go with the last step, that is nothing but find out the state diagram. Okay, now let's see how to find the state diagram here. So now we have that in present state variables. So with the help of this state table we have to find out the state diagram. Okay,